I've been banging my head on trying to master Solidity. I want it to be good, but what does it take to be good? I kept asking myself this over and over again, and I've broken it down into mainly three parts: mastering the syntax, mastering patterns, and mastering DevTools. But let's talk about syntax. With syntax, I mean you need to know how to write a mapping or a struct and not think about squirty brackets or how do I define a struct or a mapping. You don't look it up, you just know it. This was huge for me. There's just a level of comfort of being able to type out what you want to do without having to look up on how do you type it out and define it. I know this sounds simple or stupid, but it just worked for me. Patterns. With patterns, I mean simple smart contract patterns, like writing a basic wallet or a simple multi-sig contract. There are things you do based on the set of best practices and rules that apply to Solidity. Memorizing this is just beneficial. And somewhere along the line of memorizing these patterns is it just clicks. Some things just click on how to use a modifier, or perhaps, using revert instead of require. It's just like some things click along the way of you memorizing and doing brain dead exercises. Because again, if you're thinking, oh, wait, I need to send crypto to an address, how do I do that again? That just makes things more difficult and is discouraging. Whereas if you know the patterns, like, okay, hey, I need to get the address. I know there are certain keywords such as message to sender. You know how the transaction is built up. Just makes developing that much more easier. And this just makes building also more fun, at least for me. DevTools. Finally, once we learn the code, we need to operate a set of tools to build effectively. Your skills in operating Brownie, Truffle, Hardhat is essential in your overall development skills. The more you're familiar with it, the easier the development gets. You might have heard the following. You remember 10% of what you read. You remember 20% of what you heard. You remember 30% of what you see. You remember 50% of what you write. And you remember 70% of what you do. This is in essence what I try to achieve with these lessons. So what are we going to do? Deconstruct smart contracts and practice to write it. I want to show how I learned the basics in Solidity by deconstructing smart contracts, looking at the syntax, looking at these patterns, and practicing DevTools to deploy them and test these smart contracts. This is not going to be a Solidity 101 course. I'm going to assume you watched a couple of tutorials before you came here. Sometimes I will quickly go over some syntax, but it will probably go too quick if this is your first time seeing it. My focus is more on practice and getting hands-on skills. I start out with a super simple smart contract, but the goal is really to go over more and more complex smart contracts. Eventually, that you're familiar with complex DeFi constructions or anything else that you might be interested. I'm personally interested in DeFi. So without further ado, let's get into it. All right, so what are we going to do? We're going to take a look at our smart contract that we're going to practice, talk why it's useful practicing this smart contract, go over some basic syntax very briefly. Then we're going to practice, and finally do a final task to write up the smart contract based on instructions. Like I said before, this is not a Solidity 101 course, but leveling up your Solidity skills through practice, exercise, and deconstructing smart contracts. So I'm not going to spend time explaining what variables, structs, mapping, etc. are. Now in this article, I did write some notes. So if you're interested in that, there will be a link in the description down below, and then you can look over my notes about basic syntax for Solidity. The contract. This is a simple storage contract. You might recognize it from Patrick Collins' course. It's a great contract to practice basic skills. So this contract basically has three functions. Scroll down. Over here you can see I visualized it. We have a store function, retrieve, and add person. Let's take a look at what the three functions do. The store function changes the value of a variable of a favorite number. Retrieve gets the favorite number of a person, and add person adds a person to the list with their favorite number. Over here, you can take a look at the contract, but don't worry about it too much. We're going to focus on what syntax is required to master this contract and then go into practice, and then we'll write it up. For this contract, we need to be familiar with the following syntax: variables and typing of the variables, structs, arrays, mapping, and basic functions. This is the template that we're going to use to test our knowledge. Over here are instructions as comments that will help us basically write up the smart contract. But before we do that, we need to practice. I've got a set of exercises for us that we're going to go through together that will help you master the basics that you need in order to write this smart contract. Okay, so here are the exercises. The way I like to do these exercises is by looking at the question once, then the answer, then copy the questions into Remix and code the answer. Now I know you might be thinking, what's the point of doing the exercise when you look at the answer? Well, it's not like you're going to memorize the answer straight away. But if you prefer not taking a look at the answer at all, I'll make sure to have a template in GitHub where you can just take the questions and then practice the questions and exercises without looking at the answer. All right, let's start the practice. So over here, I'm in Remix right now. I'm going to create a new file called practice.sol. And over here, we're going to start practicing our questions and exercises. Let's take a look at the first question. Define a function named add numbers that takes two uint 256 arguments and returns their sum. And then this is basically the code. So I'm going to go ahead and copy the code, go to Remix. So the first thing I'm going to do is type out the license that I need, which is SPDX license identifier on my T. And then I'll define the version of Pragma that we'll be using, which is 0.8.0. And then we'll define the contract. We'll call it exercises. Save this. We get an error. We need to change our compiler because I define it as a 0.0. And now we're all good. I'm going to go ahead and copy the exercise in here, write it as a comment. And now I can go ahead and do the exercises. So we need to define a function. Let's start with that. Function, call it add numbers. That takes two parameters. There are uint 256, call this first, and uint 256 again, call this second, and then we'll just define the function this is an error default null, won't worry about it right now. We need to return the sum of them. So what we're going to do is, what I like to do is start writing what we're going to return, which is first plus second close. Now, there are a couple of things we need to still define in our function, which is this one is the visibility. We can make it public. We'll call it pure because this function doesn't interact with any other part of the smart contract. And then it returns a number. And in this case, it returns a uint 256. Then we save this and then we get an error. This needs to be removed. It's fine. And then we go ahead, it's already compiled. We go ahead and deploy it. We'll deploy it locally. And then we got it over here, add numbers. So we'll do 2 and 3, and then we get a return of 5. Cool, that's the first function. Let's move on to the second. Exercise 2. Declare a function named sayHello that doesn't take any arguments and returns a string, hello world code. We don't take any arguments and just say hello world. Okay, cool. Copy this, go to Remix, paste exercise. It's gonna hide the screen. So over here again, we need to name a function named sayHello that doesn't take any arguments. And then what we can do over here is we'll have the visibility of public, again pure, and then we need to return a string. So return and then string, and then we get an error here, and I'll cover that in a minute. So we need to return hello world, hello. Now over here we get an error because data location must be memory or call data for parameter function. None was given. So over here we need to add the keyword, and then the error disappears. Great. Go ahead. It's already compiled. We remove this one, redeploy it again. Over here we can see add numbers, but also say hello, and it returns hello world. Move on to the next exercise. Exercise 3. Define a function named isEven that takes an integer as an argument and returns a boolean indicating whether the number is even or not. Okay. So over here we use modulo. If you're familiar with modulo from another programming language, that's great. If not, I'll show how to use this. Whoops. Comment it out. Hide the screen. So we need to define a function. Function is even. It takes an integer as an argument. So we'll say uint 256. Call it number. We can make it the visibility public. Again, pure. And then we need to return a boolean. So we say returns. And so what we need to do is check whether this integer is even or not. And what we can do for that is use modulo. Modulo basically divides any given number by a number we define and then returns the remainder. So we can do return number modulo 2 equals 0. And so any number that's passed is divided by 2. Let's say we pass the number 3, 2 fits in there once. The remainder 1 divided by 2 is all, it wouldn't be a full. So let's say we pass the number 4. 4 divided by 2 is 2. So there's nothing left to be divided. And so 0 will be returned. In the case of 3, 3 divided by 2 would be 1.5. So 1 is kept. So the remainder of dividing 3 by 2 is 1. Because 2 fits as a whole only once inside of 3. Go back, deploy the smart contract. And then over here we can say 3 is even. It's false because it's not an even number. And over here we'll say 6, and that's true. Awesome. Move on to our next exercise. All right, we've done the exercises for functions. Let's move on to variables and typing. Exercise number 1. Declare a variable of type integer with the name age and assign it a value of 25 with a function. So we'll copy this over, go to Remix, paste the exercise, and then what we need to do is define the variable, uint256. We'll make it a public variable called age, and then we need to type a function. So function, set age. It doesn't take any parameters. It's public. The visibility is public. And then we set age to the value of 25. That's it. We compile the contract. Let's deploy it. Over here, if we click on age, it says 0. We set age, click age again, 25. Awesome. Let's move on to the next exercise. Exercise number 2. Declare a variable of type string with the name and assign it a value Alice with a function. Awesome. Go ahead. So we do string name, public name, and then use a function to set name public, and then we say name equals Alice. Go ahead, compile the contract, deploy it. Then over here, name doesn't have any name to it because we didn't assign it yet. Set name Alice. Go back. Exercise number 3. Declare a private variable of type boolean with the name is student and assign it the value true with a function. Go ahead, copy. So we're gonna go ahead and do bool private is student function, and then we need to set the value. So probably do set student, doesn't take any parameters, it's public, and then we say is student equal true. Save this, deploy, then we set student. Now there's no way for us to check this because we named student private. So if we do this public, we deploy it again. Right now we can see is student is false, set student is true. All right, we're done with variables. Let's move on to structs. Exercise 1. Define a struct named person with 2 fields, name of type string, age of type uint256. Write a function that uses the struct person for a variable with the values Alice and 25. Right, copy over here. And then go ahead, hide the screen. So first thing that we need to do is need to define a struct person. And then we have 2 variables in there, or types, string name, and then we have uint256 for age. Then we're going to go ahead and a variable with the struct person, visibility public, call it person. And then what we need to do is write a function where we're going to set the variables for the person that doesn't take any parameters, visibility of public, and then what we're going to do is set person equals person. Then first we're going to name it Alice, and the age, will be 25. Save this, and we've got error because we need to have semicolons at the end. Right, let's go ahead and test it. With smart contract, go over here. We can actually comment out the other stuff, but we'll do that in a bit. We have person here, nothing set yet, so set person. Then we see Alice and 25. Awesome. Then I'm gonna go ahead and actually go up here and comment out everything because that will make testing a little bit easier. Go back. Exercise number 2. Declare an array of type person with the name people, initialize it with 2 person structs, push 2 people with their age to the list, Alice 25, Bob 32. All right, quickly looking at what I need to do and then sort of get a gist of it. So the exercise, paste it over here, hide the screen. So first things first, struct person again. Oh, we already defined that, so I don't need to do that again. I've got to define the struct over here. But this time what I need to do is type an array called people. So that's not how I type an array. Type an array visibility public called people. And then I need to write a function to set the people list. It doesn't take any arguments and it's public. And then we can use the push method as I saw in a bit from the answer. And then what we push to the list is person number 1, which would be Alice, aged 25. And then we would do people up, push person, and then next one, Bob. Bob is 30. Getting an error thrown. Yeah. Always forget those semicolons. Save it. Now, if we go to deploying the contract, then we have over here people. So input required. So let's say people 0. There are no people in there. And then if I set people, you see the first one, the first element is Alice with 25. And then the second one will be Bob, and 2 would throw an error because there's no one there. Yep. Awesome. Okay, let's move to the next exercise. All right, we practiced structs. We sort of already touched upon arrays, but we're going to do some exercise for arrays. Declare a dynamic array of type uint256 with the name numbers and initialize it with 3 numbers, 1, 2, 3, using a function. Copy this. Seems fairly straightforward. Copy the exercise. Let's start writing. So first we do a dynamic array of uint256 array with the name numbers with the visibility public. Then we type a function set number, doesn't take any parameters, public, and then we basically set numbers as 2, 3, save it, delete, deploy. Then we have numbers, which throw an error right now because we haven't set it yet. Now if we do number, we get the right numbers. Awesome. Go back to our exercise. Exercise 2, define a function named SumArray that takes an array of uint256 as an argument and returns the sum of all the numbers in the array. Might be a spicy one. Well, I'll say you can save this. So over here I can see you need to do a for loop and then return. All right, go back. Like this, then so we need to define a function SumArray that takes an array of uint256 as an argument. So uint256 array memory and array. So oops, this will be a public function pure returns, and you return the sum. So oops, so we will say uint256. So what we're gonna return is a variable called sum that we initialize as 0. Then we need to write a for loop, which I'm not really good at. So for uint256 I is 0, and then we say we need one to loop until the length of the array. Well, that's for JavaScript. So and then we iterate with 1 every time, with every round. Then so defining the for loop is similar to JavaScript, if you're familiar with that. So then what we do is add. So this syntax basically is the same as doing this. So we're gonna do, and then we're gonna return the sum. Right, delete this, deploy, check it. And then what we're gonna see is SumArray. So we need to pass an array, and let's pass 1, 2, 3, SumArray 6. So that works. Awesome. Go on to the final exercise. Declare a fixed sized array of type address with the name accounts and initialize it with 3 Ethereum addresses using a function. Okay, go here. All right, so first the fixed size array, which would be type address, 3 of them, do it public, we name it accounts. Then we have a function set address, we'll call it, doesn't take any arguments, it's public. What we'll do is we'll set the account to be address, and then we'll do 0x 0 1, and then oops, 0x002, and then the final one we'll call it 0x03. Save. We get an error because I didn't close it properly, and still an error, and we still an error because we don't need to do this. We do need to do this. Pile, deploy, and then we have the accounts. So over here, they should throw an error. Oh, so 0, because initialized with no address. So, but this should throw an error. Yep, because it's out of bounds. We only have 3 addresses. We set address and then 1. There we go. For 0, we have 1, and then for 2, the third address, 3. Awesome. So we've done the array. Now we move on to the final part, which is mapping. Declare a mapping named balances that maps addresses to uint256 values. Write a function to set the balance of the address. Save this one. Oops. Copy this one. Okay. Declare a mapping named balances. Mapping that maps address to a uint256, and we call it balances. Got visibility, there we go. And then when we write a function to set the balance of an address, so we say function set balance, and then we probably take 2 arguments, which would be the address and the balance. So we would do address, and then uint256 balance, make it public. All right, then what we will do is we want to talk about balances or set balances, and then remember a mapping is not indexed, so we need to say which address we're going to target, and that equals the balance. Save. Awesome. That works, or it compiles, and then we will go and deploy. Here we see balances. If I need to pass an address, which I didn't, so there's no address to, so right now balances, it would be empty. That balance, let's do 0x001 1000 set balance, probably. All right, so we set the address, for the address, the balance of 1000, and then when we go here and check the address for balances, we see it's set properly. Awesome. So our mapping works. Go on to the next exercise. Define a function named getBalance that takes an address as an argument and returns the balance associated with that address from the balances mapping. So we go ahead to remix. We already have our mapping with balances, so we can just reutilize that one. And what we can do here is function get balance that takes an address as an argument, and then it returns uint256, which is the balance of the address. And over here, what we can do is turn balances. We'll do address like this. Say we get an error. Function can be received to view. So we'll do view because we're not altering any state or make any changes in data or anything. Go over here, deploy, exercise, and then if we say get balance, we grab an address. Should throw an error because we haven't set it yet, 0. But if I go over here and set the balance, 1000, set balance, and get balance, boom, it works. Awesome. So our final exercise before we move on to our final task, declare a mapping named student grades that maps strings student names to uint256 values, the grades. Write a function that sets the grade of a student. All right. Go here. Okay, declare a mapping. So that would be mapping student name, so it would be string to uint 256, and then we make it public and we call it student grades. Then we have a function that set grades of a student. All right, so to set the function of a student, we'll probably need to take an argument of string name, and then we also need to set the grade, and this can be a public function. So we target the student grades mapping, and then we target our student with the name and set the grade. All right, that compiles. Let's see if it works. Go down, and then we go down, set grade, student grades. Where is our mapping of, oh, that's our mapping. So right now, no student grades. We set the grade saying Raza got an A10 because we can't do A plus because it takes a uint 256. We set the grade, student grades, takes a string, of course, because mapping is not indexed. So we do Raza, and then we see the grade for Raza is a 10 out of 10. Awesome. So that was our final exercise. Let's move on to the final task. All right, it's time for the final task, which is based on the exercises. We should be able to create a contract, define a struct, use the struct in an array, create a function to add a name with a favorite number to the list, retrieve the favorite number, store a variable like favorite number. All right, we've got a blank template, and then what I'm going to do is copy it and go over to Remix, create a new file. We'll call it simple storage.sol. I'm going to paste it over here. Yep, I understand. And then we've got already the pragma defined, which is fine, but I'm going to change it to 0 because my current compiler is in 0. Got an SPDX license. Delete this. So the first thing that we're going to do is define the contract. Just contract storage. And then we need to define a variable for a favorite number. So we'll say uint 256 favorite number, and we will call, we'll make it public. Then we need to write a struct for a person containing favorite number and a name. So we'll struct person, and then we need to do uint 256, or let's start with name, string name, and then uint 256. Can't call it favorite number as well, so I will call this the favorite number, and then this one favorite number. Right, write an array containing all the list of people, hint the struct, use a struct to type the array. All right, so we're gonna go person array, make it public, and then people. Write a mapping to link the name to the favorite number. So we'll do mapping string for the name, uint 256 for the number, and then we'll call it public name to fav number. If this compiles, now write a function to store the favorite number, right? So I'm gonna assume that's in this public variable. We're gonna do function set favorite number. We're gonna take a parameter for uint 256, and then fav num, make it public, and then what we're gonna do is the favorite number equals fav num. Save. Now I'm gonna go ahead and deploy this contract, check if it works. Favorite number 0, set favorite number. I'm gonna do 0. Oh, that wouldn't make sense. To set, boom, works. Awesome. So defined the variable already, wrote the struct, wrote array, mapping, favorite number. All right. Move on to the next one, which is write a function to retrieve the favorite number. So function get favorite number, and then we'll do public view returns uint 256, and then it return the favorite number. Save, delete this, deploy, then we'll set the favorite number to 10, and then we'll get favorite number, and then if we do it 14, changes, awesome. Now we need to write a function to add a person to the list. And the list is typed as a struct person with a favorite number. So each time we add a person to the list, we need to add favorite number and the name. So we're gonna go ahead and, do function. I'm gonna call it set or add person. We're gonna take a string. A string needs to be with memory. We call it name, and then we also need to pass their favorite number. So that will be fav num. Then we do it public. And so what we're gonna do is in people list push, and then we're gonna do the type person for the struct, and we're gonna add the name, and we're gonna add fav. Oh no, yeah, we did name first, and then fav num. And that's it. Save. We got an error. Whoops. Yep. Got an error here. Wrong argument. Construct one argument given expected to. I think this is too much. That should be good. All right. So delete this one. Deploy it again. To here. When I do 0, error because there are no people in the list. And I add a person. Raza 7, 5, a person, people, boom. Added to the list. Awesome. Completed a task, and we wrote our own simple storage contract. All right, so we completed the task. We did the exercises that prepared ourselves to write up the smart contract. Based on a set of instructions, we wrote the smart contract, and we were able to define mappings, structs, arrays, and write functions to set values, get values, and even add values to a list of to an array.